Hello viewers, so I'm taking you through the story of A-level pure mathematics. And this video I'm going to go through the marking guide for Senior 5 Math 1 end of term 1 for the year 2024 for Mengo Senior Secondary School. And this video is suitable for students in both Senior 5 and Senior 6 offering principal mathematics as part of their combination. So these are the papers we hope to upload. What is ticked is what you have already uploaded. So, but today we are going to deal with the one for Mengo SS, Math 1. And there are books you'll need now that you're in A-level. For Principal Mathematics, there are 4 books for Math 1, Math 2, Topical Question Bank, and Termly Papers with marking guides. For Subsidiary Math, it is only 1 book having all notes, Termly Papers with marking guides, and also Unit Papers with marking guides. For Physics, there is Physics Part 1, Physics Part 2, Topical Question Bank, and its solutions. So you really need these books. So if you need to get them, contact the author on that contact. Okay, so now we shall begin with question 1. Question 1 says, given that this is equal to that, show that this is equal to this. So the first thing to do is to express this in terms of sum and product. I think you did that under roots of quadratic equations, where this is the same as this. The next is quadratic like terms. Take this on the side, we'll come up with that. Okay, then next is to introduce logarithms, log base 10 on both sides. Then you expand it. For this will go this side to get a 2. Then for this one, it will be split. 25 is here, A is here, B is here. Okay, but this side they want log A plus. Actually, this should be log B. Yes, so now we have edited it. It should be log B here. So what we are going to do, we are going to make this the subject. So take this side to come up with that. So this 25, so 5 squared, this 2 has come here. That's why you see a 2 log base 5. And the reason is because of this. So what I'm going to do, I'm going to factorize out 2. And this subtraction means when you combine them, you get a division into one logarithm. And that's what they wanted. Okay. Then question 2 says, solve the equation this. So first is to rearrange where this becomes 3 to the power 1 times 3 to the power 2x, which is this. Then you can now let y be equal to that and substitute for this and this. Then you can rearrange to get a quadratic equation, which can be solved using a quadratic formula to get the 2 values of y, this and that. But remember, the question wants values of x, so you should come and remember that y is equal to 3 to the power x. So 3 to the power x is equal to 3 to the power 1, and 3 to the power x is also equal to 3 to the power negative 1. Same base, you cancel and remember the powers, equate the powers, you get this, equate the powers, you get that. And that's what they wanted. Question 3 says, without using tables or calculators, find the value of this and that. So 30 is a particular angle. Particular angles, we have 30, 45, 60. So sine of a negative angle is equal to negative sine that angle. So this is a negative, and sine 30 is a particular angle, which gives you a half. Then 135, it is in the second quadrant. So it is the same as negative, because in the second quadrant, cos is negative. That's why you put a negative here. So it is equal to negative cos 180 minus 135 to give you a first quadrant angle. So negative is here, and cos 45 is the partial angle which gives you root 2 over 2. And that's what they wanted. Then question 4 says, given that this is equal to 0, find the possible ratios of x to z. X to z is the same as x over z. So I'll come here, get the equation, and divide through by y squared. Come up with that. Then take 49 on the other side and make this a subject to give you this. Put square root on both sides to get plus or minus. But remember the ratio, they want the answer in this form. So we shall come and conclude that ratio of x to y will be 7 to 4, negative 7 to 4, negative 7 to 4, and 4 to negative 7. We would also add negative 7 to negative 4, but negative 7 to negative 4 can still be reduced to this. That's what they wanted. Then question 5, solve the equation that. So first is to change them into the same base. So convert this to base 2, you come up with this. 4 is the same as 2 squared, so you come up with 2 log 2 of base 2. This cancels, you remain with only 2. Then you can cross multiply. Okay, but to cancel the logarithms, this has to go this side, so you remove it. And then now you can cancel this with this because quotient is positive 1. Then I rearrange to get a quadratic, which can be solved using quadratic formula to get the two values of x. But log base cannot be negative, so you conclude. Therefore, x is equal to positive 2. Then question 6, without using tables or calculator, find the value of x for which this is equal to this, and this is equal to that, where values of x range from 0 to 90. In other words, they are acute. So for Roman 1, first of all, we know that sine A is the same as cos 90 minus A. Therefore, because this is cos, I'm going to change this to also cos by saying this becomes cos 90 minus 20. Then from there, I can now cancel the cos to remain with this equal to this. Then make x the subject, which will be 85, and that's what they wanted. For Roman 2, still do the same. This is sine, meaning I have to change this to sine. So I'll come and say this becomes sine 90 minus 50. Then cancel this to equate the angles. Then make x the subject. And that's what they wanted. Question 7. Express this in the form this, and hence find the minimum value of the expression and the value of x for which it occurs. So they want you to complete squares. So complete squares, this is the formula for this one. This one becomes this. So shall come here and let y be equal to what is given. You realize that here quotient is positive 1, so I'm going to factorize out 3 to remain with this in the box bracket. Then this is what I'll compare with this to complete squares. So I'll come up with this. This half of this is 1 minus this squared to give you that. Then you can open this box bracket to get what they want. So in this form we have this. Then for the hence part, Minimum value occurs when the squared term is equal to 0. So that means the value of x is 1. Therefore, the minimum value will be this plus 0, which is negative 2. And that's what they wanted. Question 8 says, without using tables or calculator, find the value of this in the form this. So the good thing, 60 and 30 are particular angles. So this becomes this and this becomes that. Then get LCM for this to give you this, LCM for this to give you this. So I come up with this in the numerator, this in the denominator. Then we have to rationalize the denominator. Expand, you'll come up with that. And that's what they wanted. Then now we shall go to section B. So question 9 says, simplify this. I think let's begin with that. So first is to remove this square root and put their power a half. So this will be power half, and this will also be power half. So I'll try to rearrange. You see this a half, it's better when it's starting, followed by that, which is okay. Then also here this, followed by this, followed by this. Okay. Next is to identify the common factors. Now, common factors, how do you identify? First of all, this a half and this, that means it is already common. Okay, we have x minus 1 minus x power half, 1 minus x power negative a half. So what you do, you look for the smallest power. Smallest power is this, that's why you put it out. Go to also 1 plus x power negative a half, this one is power a half. So this is smaller, that's why you put it outside. Now, how do you get these terms? These terms are got by dividing. So if I say this, divide by this, what will happen? You realize that these are, okay, let me compare with the other one. We say this, divide by this. When I divide, you see what will happen? This a half will cancel this a half, okay. This one will cancel with this, okay. Now these ones, the powers are different, but the same base. When you divide the same base, it means you subtract the powers. So a half minus negative 1 is power 1. That's why you see it here. Then do the same for the second term. This divide by this. Okay, this a half, then this will go. Now here, this same base, but this power half, this is power negative a half. So same base, it means that you subtract the powers. A half minus negative a half is positive 1. That is why you see 1 plus x power 1. So that is how they come about. Next is to simplify again. So the whole of this is here. Then I want to open this box bracket. So this cancels with this, and this with this gives you 2, which is here. Then this one, to go up, it becomes a negative power. Then I can collect like terms, this and this. Then also this cancels with this. So this plus this gives you negative 3 over 2. Then I can make them positive indices by taking them down. Then I can put a third, which can be simplified to give you this. So that's what they wanted in part A. Now let's go to part B. Part B, it says the roots of the equation, this are this and that. Without solving the equation, find the values of alpha squared plus beta squared. 1 over alpha plus 1 over beta. Alpha plus 1 times alpha beta plus 1. So first of all, we are given that equation. Therefore, sum of roots will be negative of this over 2, which is here. And product will be this negative 4 over 2, which is here, to give you that. Then I'll begin Roman 1. Express this in terms of sum and product. Then substitute your sum and your product to give you that. Then for this one, still get LCM. Up replace the sum, down replace the product to give you this. Then for Roman 3, expand to get that. Then this is the sum, this is the product. So substitute product, sum. Gives you that, and that's what they wanted. Then question 10 says part A, prove that this is equal to this. So let's start with that. So first of all, this is common, so I can pull it out to remain with 1 over this plus 1 over this. Then I can get LCM. LCM of this, I'll come up with this. Then I can expand this cancels with this to remain with only 2. 1 plus 1 is 2, which is here. Down is the difference of 2 squares to give you that. Then this is an identity, it gives you sine squared. So 1 sine goes with this to remain with 2 over sine. And 1 over sine is cosec, and that's what they wanted. Then part B says, solve the equation this for values of x ranging from 0 to 360. So first we shall rearrange, take this to the side to get this. Then you factorize by grouping. So group this and factorize it, group this and factorize it. So this factorized gives this factorized gives that. Then these are common, so I can pull it out to remain with 5 sine x plus 2. So for this equal to 0, this is equal to a half. For this equal to 0, sine x is equal to negative 5 over 2. Then you can get the corresponding values of x. So for this, we have this and that. For this, we have this and that. So that's what they wanted. Question 11, part A says, a straight line, this, cuts the curve this at points A and B. Find the length of AB. So the points of intersection will be got by solving these two equations simultaneously. So this make x a subject to get that. Substitute here where there is x, to put there this. Then you expand to get a quadratic, which can be solved using a quadratic formula to get the two values of y. So when y is 12, you have to go here and get the corresponding value of x. Similarly, when y is negative 4. Let's see the marks for this slide. So when y is 12, x is 18, meaning you have point A, which is that. When y is negative 4, x is 2, meaning you have B, which is that. Now the distance between A, B can be got by that change in x values squared plus change in y values squared. So we'll come up with that. And that would be the answer they wanted. For part B, Part B says, find the equation of a line through the point -1, 2 and is parallel to the line this. So parallel lines have the same gradient. So I'm going to first get the gradient for this. So the gradient is a half. And therefore the required equation will be got by equating gradients, change in y over change in x equal to gradient. Cross multiply and rearrange to get the equation they wanted. Then Roman 2, they want to pass through this point and is perpendicular to this. So y is equal to 0 is this line, y equal to 0. So parallel line is this, x equal to 0. So the perpendicular line is x equal to 0. Now they want a line which passes through point -1, 2. So that line should be this. And that line will be x equal to -1. So here what they wanted you to do is to state like that, and that's what they wanted. Okay. Then question 12, part A says, given that tan theta is equal to this and that theta is reflex, without using tables or calculator, find the value of sine theta and sec theta. So theta is reflex, meaning it is greater than 180. So it's either this and this. But because in this quadrant tan is negative and in this quadrant tan is positive, we shall conclude that theta is in the third quadrant. So we shall come and draw a triangle in the third quadrant. Opposite, adjacent. So this can be got from Pythagoras. Then I can now get the value of sine. Sine is negative in the third quadrant, so it will be negative opposite over hypotenuse. Sec is the reciprocal of cos, so 1 over cos, it will become negative hypotenuse over adjacent. And that's what they wanted. So part B, said, given the parametric equations this and that, by eliminating theta, show that the Cartesian equation is this. So we shall come here, and so that let us start from x is that, y is that, and we're given that. So let me start from the left hand side and see if I get the right hand side. So right hand side I will substitute x squared, put there this, 1 plus y squared, put there that. For this I have to expand. It gives this, then this one's an identity which gives sec squared theta. Then here there's an identity for this, which is 1. Then I open brackets, say this plus times that is this times this is that. But sec squared theta is the same as 1 over cos. So for this one, we just replace in terms of tan, 1 plus tan squared theta. But for this, we change to become 1 over cos squared theta, where 1 cos goes with this, and 1 with this gives you tan. Now that is a quadratic which can be where you can complete squares. The good thing, this question is already a positive 1. So we shall say 1 plus tan plus a half of this, which is 1, minus this squared, which is here. Then you simplify this, cancel this, remain with this, and replace y, and that's what they wanted. Then question 13, part A says, solve the equations, these ones. So let's begin with that. So we are given those. From that equation, we want to eliminate logarithms. So we're going to first combine this with this to give this. Then the good thing here, equation is positive 1, so I can cancel these two to get equation 1. Then for this one, this becomes 2 squared. So same base, you cancel to remain with that. So there are two equations, two unknowns, which can be solved simultaneously. The good thing we have this, we have this. So I can substitute for x to come up with that, take everything on one side, factorize, and get the two values of y. So from equation 2, when y is 0, it means that 0 is equal to 2x, implying that x is 0. And when y is 1, it implies that 1 is equal to 2x, implying that x is equal to a half. And that's what they wanted. Then for part B, solve the simultaneous equations. So we shall come and first label them, then we look for what to eliminate. I've chosen to eliminate z. So I'm going to say equation 1 times 2 added to equation 2. This is what I'll come up with. Then when I add, this is 5, this is 3, this is 0, and this is 14. Then equation 1 plus equation 3, I'll come up with this. Add, this is 3, this is 5, 0, 2. Then now I can solve these two equations simultaneously to get the value of x. So this minus that, this 0, this minus that. Then I divide both sides by 16 to get x. Now from equation 4, I'll substitute for x to get the corresponding value of y. And from equation 1, I'll substitute for x and y to get the value of z. And that's what they want. So that brings us to the end of this video. Thanks for watching, and be reminded the next video will be on marking guide for Senior 5 of St. Joseph. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the new video has been uploaded. And also, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so you can all benefit